In turbulent flow, the chaotic motion of fluid motion on contaminant particles may be modeled by the random walk. The random walk model assumes that each particle is advected by the main current and displaced longitudinally, vertically and laterally by turbulent structure. With increasing times, the particle becomes separated further and further by the random chaotic motion. This photograph and the following movie show some dye dispersion in a turbulent pipe flow, with the main flow direction from the right to the left. The random walk model simulates discrete mixing at a series of time steps. Each step is uncorrelated to the previous one, assuming a homogeneous and stationary turbulence. For a long diffusion time, the location of the centroid is x equal Vx times t, where Vx is a longitudinal advection velocity. During a time step delta t, a particle is advected in the x direction by the ambient current and moved randomly by the turbulent displacement, and its net change in position delta x can be expressed. For a long diffusion time on a large number of particles, the random walk model yields a standard Gaussian distribution. This may be extended in the y and z direction for a three-dimensional flow. The random walk model can also deal with boundaries. The following two examples illustrate two-dimensional random walk of particles. In both cases, the advection velocity is 1 meter per second. The first graph shows the data for turbulent mixing coefficient of 0.001 square meter per second. The second graph illustrates for the same advection velocity the dispersion of particles with a diffusion coefficient 10 times larger. A related model is Langevin model of turbulent dispersion. Shortly after Albert Einstein identified Brownian motion, Paul Langevin formulated a theory to model the velocity of a particle undergoing Brownian motion. This photograph illustrates, on the left, Albert Einstein in 1921, in the middle, a meeting with Paul Langevin in the middle, Albert Einstein and Paul Ehrenfest on the left, Heikki Honnes and Pierre Wess on the right. On the right photograph shows Paul Langevin in the 1930. The random walk model is a fundamental concept for the transport of contaminant in turbulent flow. This and other concepts are discussed in the relevant YouTube video movies in the same playlist.